welcome everybody. I'm quite impressed. Thanks for coming today. This is our OpenIO Summit #2, this time in Paris. Last year we did it in Lille, north of France. Well, I hope we'll have a great day. I will let the floor to Enrico, who will tell you a bit more about what's coming today. Thanks.
Thank you, Laurent. Thank you, everybody, for coming here today. And I am Enrico Signoretti, and evangelist here at OpenIO. So this is, for us, as Laurent told you, the second summit. And it's quite interesting to see the evolution of our company in this year and what is going to happen next. What I want to tell you, first of all, this is a day of learning, okay? So you will learn a lot about our company, a lot of our team, and about our team. But also, please share your experience with us, the experience that you had with object storage in general, with your storage infrastructure, but also applications, use cases, whatever. So we are here to listen, to learn from you, not just you to learn about the product, but we want to improve the product and everything that comes with it. Also, keep in mind that today is also a day of networking. Okay, we will have a lot of networking moments during the day, coffee breaks. All the sessions are interactive, meaning that you can raise your hand, ask a question, and somebody, I hope the presenter, will answer you. Okay, we will have roundtables later in the day, as well as party. I came here only for the party, actually. So, and a big thank yous go to all our partners that made this day possible, as well as customers and you. So you will have the opportunity to learn from them today what they are doing with us, what they did with us, their success stories, and what they have in mind for the integration between us and their product, for example, and so on. So look in the program, you will find, looking in the program, you will find all the session with a specific partner or customer or partner or customers. So why next generation object storage? Okay, we define ourselves next generation. Next generation, for people that already had an experience with object storage, means a lot of things. Okay, usually object storage is seen as a very rigid, complex to manage kind of environment. The dollar per gigabyte is very low, especially if you have very large infrastructure. But it's not meant for a lot of workloads, okay? So we are going to change this paradigm, and we are making a point by saying, for example, that we are flexible. Because our flexibility is well known from our customers, okay? Yeah, the guy, it's weird, right? The slide, it's quite, I don't know how he managed to put the leg in this way, but okay. So there are a few things that makes our product different, okay? First of all, the core product developed in C, and it's very, very lightweight. Still today, we can manage to run in a Raspberry Pi, but not the Raspberry Pi, the latest version. We are managed to run it on a Raspberry Pi Zero, so in a $5 computer, okay? 400 megabytes of RAM, and one core CPU, ARM CPU, not even x86. This means that the product is highly optimized. And this opens a lot of use cases, okay? Not just the fact that we can run in large data centers, but we can run in a small edge device in remotely installed, I don't know, in the middle of the ocean, for example. Then there is flexibility. We design a technology that we call conscience that helps the system to understand what is happening all the time. And it does dynamic data placement, so there are no hotspots. So we overcame a lot of the limitation of traditional architecture in the object store because this technology. Okay, so when you add a new hardware, for example, it's possible, okay, to use a different kind of node, which is again different from what you see from the usual players. And of course, the flexibility is not just the product, it's not that the technology, but really, I am impressed every time I talk with our engineers. We have a sort of a team of Guillaume, please. Can you stand up? Because Guillaume is like, you know the guy, I don't know in English as well, but the guy on the left. And the customer, you know, we recognize him, right? He's the guy that sells you. Okay. And, but this was the beginning, right? So we talked about flexibility since day one. Okay, some of you know the OpenIO team for years now. Last year, okay, almost 2 years ago, we started to talk about smart. How can be an object store that could be smart? No, right? It's dumb piece of hardware and software put together that stores in a flat namespace data. You say, oh, it's not smart. Actually, we changed this. Okay, we started working on the fact that our technology, okay, is different. And as I told you, it's so different that we can also run on the edge. So we have a lot of resources that we are not using in our system. Most of our customers tell us, look, we have these huge servers with a lot of disks. You have forced us to buy multiple CPUs and a lot of RAM because these, usually the others need this. But then we have plenty of cores, you know, doing nothing all day. Okay, good, we said. We can take advantage of them. And we built a serverless computing framework. Okay, the serverless computing framework is actually a very simple object. So we can catch any event that happens at the system level. So when you write data, when you read data, update data, metadata, and so on, we understand what is happening, and we can trigger some code to do operations. Okay, some customers already started to use it, and of course, this is by design. Okay, so all this mechanism was designed from day one. Okay, all the event catcher was ready there, and now we implemented the function part, so you can write your code. Of course, we changed it a little in the last year, and you will see from now on why we are not talking anymore about a separate product, okay? Because for quite some time we thought, okay, guys, this is crazy cool, okay? So we have a serverless framework. But then we look at the market. Actually, it's not that cool because there are 20 different serverless frameworks out there. Okay, what is the differentiator between OpenIO and all the others? So we changed our mind. We said, okay, we optimize our product, okay, to become a feature of our OpenIO SDS. So the grid for apps is now a feature. It's no longer a single product. You can theoretically buy it as a separate product, but the idea is that we are moving some of the features that are on the core or are meant to be on the core as functions. Okay, why this? It's very important to maintain the light core and move features on the upper layers, because with this integration, we are able to maintain a very good quality in the core, on the code. We don't need to change the core too much, but at the same time, we are very, very nimble when it comes to add new features, okay? Think about automatic tiering, okay? Automatic tiering is that feature, I don't know if you ever heard of it, but it's a feature, it's a very simple feature. So you save stuff on a kind of media. After a while, this stuff becomes old, and you want to put it in a slower media, okay, to save money. We can develop it on the core, but actually, it's a time-based function, okay? Or you can trigger it for any other reason. Why not writing the piece of code as a function, we thought. So we moved this feature on top. What happens? The feature is, you can customize the feature. You don't like how we think about doing the data movements? No problem. You have the code, you can manage it. You want to write a different automatic tiering? Yes, you can. Okay, it's easy, it's flexible, again, and it's fast. And why we think about fast? Okay. Once again, usually object stores are thought as very slow kind of storage systems. We are changing this paradigm, okay? So today they are not with us because they come from Japan. It's a little bit far for a one-day event, but one of our customers actually deployed an object store, all flash, that is meant to store emails. They store 5,500 emails per second. Okay, so it's a huge number, and it's built around a very small cluster at the end because Flash is very fast, and emails are small. Actually, okay, this is not something that you can do with any object store. So we did a lot of optimizations in the past years to make it happen. The lightweight core, again, makes it happen. And the design, so comes a bake again in this presentation, but it's true that we are working to build even more presentations. So we are working with hardware vendors to shorten the data path, to make it faster. Okay, we are working with NVMe, which is a flash memory technology. Okay, so it's a protocol to access flash memory, but it means that we will remove a lot of steps to go from the data, go and back from the data. And again, it's about integration. So in the moment that we build function integrated in the object store, okay, so the serverless computing part, or functions as a service, I don't know how do you, serverless is a very bad name, I think, because it's not that we don't use server to make serverless, but the real thing is that this integration will allow you to do a lot of things on data directly. Today you will see presentations, one with, from Julien, for example. He built an indexing engine on top of the OpenIO SDS, taking advantage of the serverless computing part, and you can do the same. Okay, but when you start to do these kind of things, there is a lot of compute involved, and there is a lot of back and forth from the object store. You want data close to the CPU again, okay? So you need to have faster access. The integration is really important there. Okay, so this is why you will find these three words. Now this is our new payoff, okay? Flexible, smart, and fast. And as you saw in my presentation, they are strictly connected to each other because we make it flexible at the beginning, but flexible allows us to make it smart, and now we are working to make it even faster, okay? And then again, we will start to work on the flexibility. So this is what you will learn today about our product, and I hope you will enjoy the day.